And as we all know, this is still an open issue. There's still lots of discussion at ICANN about how at-large advisory committee works and how board members can be chosen so that they look at the whole picture and the needs of the entire Internet community. I should say that since I worked at the White House, there have been a number of very strange accounts of the early days of ICANN. In the US, we have a saying that you should never read news reports of things that you know something about. That's certainly the case in this case. I've read some amazing things about the government conspiracy behind the creation of ICANN. Having worked in the US government at the highest levels, I can assure you that the phrase government conspiracy is an oxymoron. In Washington, one of the other rules, one of my 50 rules, is that if 3 people know something, one of them will leak it. So the only government conspiracies that can exist consist of 2 people who both know that they've told no one else. But that's a very small government conspiracy, and you can't do very much. So I think it's fair to say that we have made some good progress in the 10 years since the white papers, and that as a result, we have an Internet that is still functioning, we have a domain name system that is still functioning, and we are no longer discussing whether we need to have an ICANN or whether we need to have management. Let me now move to the next piece of this talk, which is Act 2. Where are we going? This is a chart with some numbers demonstrating just how fast things continue to move. If you look at the cost of computing, the cost of chips, we see that every 4 years you can buy 10 times more computing power. Every 6 years you can buy 10 times as much storage. And the capacity of the network itself is improving even faster. As we go from dial-up to DSL to fiber, it's now routine in many countries to have 50 or 100 megabits per second into the home and into businesses. When you take these 3 trends together, we find that the total amount of information being generated and being accessible on the net has increased by a factor of 1,000 every 5 years. We're on our way to a zettabyte of information. That's 1 followed by 21 zeros. That's not all new information. In many cases, it's old information being put online. In some cases, it's not all unique information. In some cases, it's 1,000 copies of the same stuff. And it's not all text. As a matter of fact, most estimates are that by 2011, 97% of the information on the net and 97% of the traffic will be video. That leads me to this very important conclusion, and that is that the Internet revolution is less than 15% complete. This is a wonderful bumper sticker. Unlike many bumper stickers in Washington, it happens to be true. Even better, you can prove it in at least 5 different ways. You can count up the number of people online, the amount of devices we have, the amount of content, the number of applications. They're all going to increase by at least a factor of 5 or 6 over the next 10 or 15 years. So we do have a long way to go, and we should never forget that. We have data being generated at an incredible pace. As I said, a lot of it's video monitoring, video surveillance. We have new location-dependent services, video conferencing, and we have sensor nets developing. So very soon there will be far more sensors online than PCs. Each of us will have 50 or 100 devices that somehow interact with the net. Not just my laptop and my cell phone, but my furnace, my sprinkler system in my yard, my kids, my dog, my car. They'll all have some way of interacting with the net. This chart illustrates what really is happening. As I said, the number of computers is now over 1 billion online, but we also have cell phones and appliances, and we have the yellow line, which are the sensors, which are going to predominate on the Internet in just a few years. So we're going to hundreds of billions of devices and sensors somehow interacting with the net. The other big trend is what I call cloud computing. There are many different terms that are used to express this concept. Software as a service, Web 2.0, Web 3.0, utility computing. But the key point is that this is a fundamentally new approach to computing. And it is as important as the web. It's about creating a computing platform on the internet. A computing platform that will give companies and individuals access to all the data, all the storage, all the software, all the computing power that they need to respond to any customer demand, any new market opportunity, or any threat. And this is fundamentally different. We can't stress this enough. When we're talking to our partners, our customers, politicians, the press, we have to get the point across that this is a new way of doing business. In the first phase of computing, we all just bought a computer and we ran our software in the computer and we did great things, but it was separated from the rest of the world. Then the web was created, and now the data was spread all around websites around the world, and our browser gave us access to that. The cloud is the next step, and that's where both the application software and the data reside in the cloud. And what's powerful about this is that it's more reliable because you have automatic backup. It's more versatile because you can tap into different applications in different places and you can combine them together. And the most important thing about the cloud is that it allows many different people in many different places to go into the cloud and collaborate. Whether they're collaborating to do a project for their company or to generate sales leads using a product like Salesforce.com, or if they're going to a virtual world like Second Life or a war game, an online game. That's all cloud computing. It's all about doing the computing somewhere else in the cloud. And it's not just about hooking up computers. My digital phone will now interact with the cloud. My digital camera. My light bulbs in my house might be controlled by the cloud. Even my dog will be on the cloud. There are already dog collars that have a GPS receiver on one side and a Wi-Fi connection on the other. So you can go online and find out what backyard your dog has wandered into. There are lots of different versions of distributed computing. We hear a lot about peer-to-peer. This is a chart showing the different ways to think about the cloud. On the right side, we have networks of PCs, relatively unsophisticated computers, but we have hundreds of thousands of them. That's what Napster is. That's what SETI at home is. On the other side, down here, we have grid computing. This is where you take very large machines, large servers, storage systems, supercomputers, and you link them together with very high-speed computers, high-speed networks, gigabit networks in some cases. What's really exciting, and is really the next phase, is what I call the holy grid. This is the holy grail of computing. It's when millions of computers and cell phones and sensors and storage systems are all integrated together, not just moving data back and forth, but actually computing together as a virtual supercomputer. So that's where we're going. This isn't 10 or 15 years away. This is happening now in special niche applications, and it will be the way that many of us do most of our computing in just 4 or 5 years. Eric Schmidt, the CEO of Google, projects that the cloud will be responsible for about 90% of all the computing that we do in just a few years. His hope, of course, is that most of that computing will go on in Google data centers.